So we are doing quiz review for quiz 2, quarter 4. First things first is we've got to talk about vocabulary, and this is asking for the arithmetic series. Remember, a series is a sum of the sequence. Arithmetic sequences are in the form or the rule of T of n equals A1 plus the common difference, which you guys know is your slope, times n minus 1. You won't always need that, but when in doubt, try to find the rule. So for the first one, we are given A1, we're given our last term, and we're given our number of terms. So we can plug that right into the formula that we know and love so well, which is going to be first term plus your last term divided by 2 times the number of terms. Now, a lot of people during class today, and I've just seen it kind of over the time, when you plug in these things into the calculator, can give you that wrong answer just because of the way that it's plugged in. So we have to be careful. So we have 4 plus 88 divided by 2 times number of terms, and that leaves me with 598, which in that case is C. Number two, we have our first term, we have our common difference, and we have our number of terms, but we don't have our last term. So we have to find what our equation is. So in this case, our equation is going to be T of n equals 13 plus 8 times n minus 1. Okay? We know our first term is 13, but we don't know our last term, so we'll just plug in 11. So now we have 13 plus 8 times 11 minus 1. 13 plus 8 times 10, which equals 93. So we have our first term, we have our last term, and because this is our last term here, our A of n equals 93. And we have our number of terms, which is 11. Our first term was 13 because it was given. And then we're just going to plug it right into that formula that we know and love. First term plus last term, so 13 plus 93 divided by 2 times the number of terms. Yeah. 583. Perfect. Okay. The next one, we've got it in sigma notation. The cool thing about sigma notation is it gives you the rule, right? So you don't have to find your rule. This is your rule or your T of n. So you don't have to find that. The bad thing about sigma notation is it doesn't give you what the value of your first term or your last term is. But it does give you the fact that you're starting at term 1 and your last term is 7. Not value 7, but term number 7. So we're going to 7 terms.
What?
That's a 7 right here.
So that's the last term?
That's the term, that's the number of terms essentially.
So is that like n equals 19 on 5?
Mm-hmm.
Wait, so where does it tell you how much is being added or subtracted?
So great question. So first we have to plug in 1. So if I plug in 1, because I have to know the value of my first term. So if I do that, it's going to be 10 times 1 minus 14, and that's going to be negative 4. Right? And then I need the value of my last term. So I'm going to plug in 7. So 10 times 7 minus 14 is going to be 70 minus 14, which is 56. So now I have my first term, I have my last term, and I have my number of terms, right? So it's going to be negative 4 plus 56 divided by 2 times 7. Negative 4 plus 56 divided by 2 times 7. 182. Yeah, so far so good? Okay. Again, number 4, we have in sigma notation, and I haven't changed the instructions. So we are still working with arithmetic series. So we're summing them, the sum of the sequence. We're given the rule. So this is our rule. We need to find our first term, our last term, and do we have our number of terms? What's my number of terms?
13.
13.
Yeah.
So my first term, I plug in 1 for k. 2 times 1 is 2, plus 3 is 5. My last term, I'm going to plug in 13. So I have 2 times 13 plus 3. So that's going to be 26 plus 3, which is 29. Right? Right. So now I have 5 plus 29 divided by 2 times 13. Now, I almost did exactly what I would tell you guys not to do. Watch. If you just did this, 5 plus 29 divided by 2 times what? 13? I'm going to get the wrong answer.
But then I did it the right way. That's because you know.
Right? Because your calculator only knows how to do order of operations. So the way your calculator read this was 29 divided by 2 times 13 plus 5.
Shouldn't the calculator know?
It is only, it will only know what you put into it.
So put it in the thing, man.
So what I would do is every step of the way, 5 plus 29 is that, divided by 2 is that, times 13 is that. 221? B. Okay. Now, most of you guys got through 4 with very little issue because you could figure out what you needed. But when we got to 5, that's where we were a little bit more confused. So, again, we're doing the series, and so we need A1, AN, and N. Are we given A1 for 5? We are. It's 4. Are we given AN for 5? We don't have the rule. And then 19 is N. So let's find the rule, okay? The rule here, we know that we're adding 6 each time. So it's T of N equals 4 plus 6 times N minus 1. I can find the value of my last term. So 4 plus 6 times 19 minus 1, which would be 18. 6 times 18 is 108 plus 4 is 112. And now we're going to go back, circle back, and we're going to use what I know how to do. Is that better, Eliana? Can you see that better?
Yes. Thank you.
You're welcome.
I was struggling.
I saw you. All right. So then we're going to, we have 4 plus 112 divided by 2 times the number of terms, which is 19. And again, this is where you have to be careful with your calculator. 4 plus 112 is 116. Divided by 2 is 58 times 19 is 1102. All right, number 6. Number 6 is one and the same, okay? We're given our first term is 26. We don't know what our last term is, and we know that our number of terms is 18. In order to find the value of the last term or the value of the 18th term, we have to write the rule. So to get from 26 to 31, we're adding 5. 31 to 36, we're adding 5. So the rule, or my common difference, is 5. And so it's T of N equals 26 plus 5 times N minus 1. That should be 26, not 25. And then if we plug in 18, we have 26 plus 5 times 18 minus 1, which is 17. 5 times 17 is 85, plus 26 is 111. So the value of my last term, here my terminology, I'm being very particular with how I'm saying things. The value of my last term is 111. The number of my last term is 18. So now I have first term plus last term divided by 2 times number of terms. Also, guys, if you get a decimal, why should that alert you that you did something wrong?
Because there was no decimals in the multiple choice. It's always an integer. Because of everything.
So how can I add whole numbers? How can I add integers? They're all integers, right? Am I adding whole numbers? 26 plus 31 plus 36 plus 41 and get a decimal.
But you can divide by 2 and get a decimal.
You could, but then we're multiplying by a number of terms and that'll take the decimal right out again.
But then if you get a decimal at the end, it's wrong.
Yeah. The general stop check. If you get a decimal at the end of an arithmetic series that you're not adding decimals in, it's wrong.
Okay. Wait, how would I check that? If it's a decimal, it's wrong.
Okay, but like that's not checking it. That's just
No, that is. Then you redo it.
Then you go back in and check your work.
that's a lot of work.
Well, welcome to math class, dear. All right, remember I said to skip 7 and 8 for now. They're completely doable, but they are a little bit more intense than what I'm gonna have you do in the quiz.
So it's gonna be a lot easier than this.
It will be a lot shorter. There's only 12 questions on the quiz.
Like in total, or like about this?
In total.
Oh,
All right,
still a lot.
evaluate each geometric series as described. Geometric is a little trickier, okay? Geometric's a little trickier, but we've got some tools in our tool belt to help you. You good? Do you need to stand up? I know, I saw her take a tumble. Eliana forgot how to sit in chairs today. So glad I record things like this. So glad. Aren't you so glad, Eliana? Okay, so we've got some tools, and I'm actually just going to go ahead and write them up here. Depending on what you're given for a geometric, we're going to be multiplying or dividing by a constant, okay, is what you're going to use. First of all, it's going to tell you. I'm not going to surprise you on the quiz and say figure it out. It's going to tell you geometric or arithmetic. It won't always be the case, but it is for this, okay? If I give you first term, last term, and your common ratio, you're going to use the formula S of n. It always makes me think of a snail. I don't know why SN. It makes me think of a snail.
Yeah.
A little weird. It's fine. So you're going to use SN equals common ratio times AN minus A1 divided by common ratio minus 1.
Wait, I didn't get any of that.
I know. If you are not given this, if you are just given A, which is your multiplier, I'll go back.
Okay.
Here. Right. My coffee is getting in the way. Is that better? All right, if you are just given A, which is your multiplier, and your common ratio and your number of terms, then you're going to use the formula SN equals
N minus 1.
A times 1 minus R to the N divided by 1 minus R.
Why is it not N minus 1?
So these are both series. What you're thinking of, Kenzie, is the sequence, which you might need sometimes too. That's that T of N equals a times r to the n minus 1. This is the sequence. These are the series. Remember, this is to find any term value. And then this is to find the sum. Yeah? Okay. So, for this one, we're given our first term, our last term, and our r. Which one are we going to use? This one, the right, or the left, or the right? Yeah. Okay. Oops. So we're going to use the yellow one, yeah? Okay. So it's going to be -2 times 64 minus -2. Nope, I'm sorry. Minus 1. Divided by r minus 1. Again, this is where that calculator work, it's going to get really sticky if you put stuff in your calculator the wrong way. So you want -2 times 64. That gives you -128 minus 1, which is -129, divided by -3, which is 43. Anne's back.
She had to get water.
Yeah.
My fountains are broken. I didn't get water.
Do you guys,
Girl.
I don't know what you guys would do. Okay, now the next one, look what we're given.
You have to use the sequence.
Huh?
You have to use the sequence.
Nope. Nope, because look, so we're given A1, AN, and R. So which one are we going to use, yellow or green?
Yellow. Green.
Yellow. A1, AN, and R. Okay? So once you guys figure out which thing to use, it's just what you're given, right? All right, so it's 5 times AN, which is -2343.75, minus A1, which is -3, divided by 5 minus 1, which is not.
All those equations that you wrote, those are only for geometric sequence?
These two equations are for geometric, yep. This one is for arithmetic. That actually didn't even write the arithmetic one. Arithmetic is A1 plus AN divided by 2 times N. Math is so funny. All right, and so then we're just going to put that into our calculator. Right? So we're going to say 5 times, if you want to do parentheses, you can, -2343.75, close your parentheses. It gives you that number here, which is what, 1171,875, minus a -3, so +3. And then we're going to divide that by 4. So -2929.68. Huh? Oh my word, I gave the formulas to you in class. I put them on the board, and I told you to put them in your learning log yesterday. I cannot make it any easier. I'm color coding it. She's giving me the look. She's giving me the puppy dog eyes. Okay. So we haven't changed directions yet, which means we're still using geometric. Oh, that's beautiful. Thank you. Okay. But look what we are given, ladies and gentlemen. Well, actually, ladies, because there's no gentlemen. Look what we are given. We're given A, 1, R, and N. So what formula from over here are we going to use if we're given A1, R, and N? Yeah, and this is actually the same as A1.
Can you go back to the front page real quick?
This right here.
Yeah.
Mhm. Hope, you were here for like 2 seconds.
What?
You were not here very long.
I know. Sorry. I was with Caroline. That's immediate zero. That's a great excuse.
All right. Caroline's actually probably really good at this.
Did you do my test?
All right, so we're going to use the formula
You just told me.
A1 or A. 1 minus R to the N over 1 minus R. Negative 2 times 1 minus 5 to the 8th power. Well, that was supposed to be an 8. That was really bad. Divided by 1 minus 5. Negative 2 times... So this is where it gets sticky, and it's like that calculator work. So negative 2 times 1 minus 5 to the 8th. 78, 12, 48. Divided by negative 4. So negative 19, 53, 12. Don't get scared by the big numbers. I know they can be intimidating. You just have to be confident you're using the formula. So here, we're given A, R, and N. Are we going to use this formula or the other one?
Wait, I got this. Not the one. Oh, wait, this one. I was gonna get that. You're bringing it up. It's the gray one.
So our A is negative 2. Be really careful though, because sometimes the A is not given, and if it's not given, you're going to assume it's 1. I'll show you when we get down to 14.
Like you're supposed to assume it's one? Right?
1 minus 6 to the 7th divided by 1 minus 6.
Are you supposed to assume it's one?
What?
Are you supposed to assume it's one?
I'll show you where you can assume it's 1.
Is that why it's A1?
Negative 2, what?
Is that why it's A1?
No, A1 just denotes it's the first term.
I'm confused.
1.
How'd you get A parentheses 1 minus R n over 1 over R?
That's formula.
That's not
r into the negative.
Yes, but I don't have food for him right now.
That's for geometric.
It's for,
So there are 3 equations.
there's
for
2 equations for geometric. There's this one, and then there's the other one where you use first term r and last term.
This chair is very squeaky.
Huh?
This chair is very squeaky.
Okay, so here we've got sigma notation. We know it's geometric because it's to the power of something, okay? And it's being multiplied. So we gotta pull a couple things out here. My A1 is -2. My R is -2. That's a little confusing, but here, look. This is A1, this is R. Okay? And then my N is 9. So I have A1, R, and N. What formula am I going to use?
The a parentheses 1 minus r.
To the N
Yeah.
divided by 1 minus R?
Yeah.
Yep. I'm glad they did this one because this is important. Okay, see this right here? So it's 1 minus -2 to the 9th. I really should have put parentheses here because order of operations is going to say I'm going to raise that -2 to the 9th power before I subtract it from 1. If I did what I would do, like looking at it, which a lot of people have done, they go, oh, negative is a positive. But you can't do it in this case. Right? So you put it on your calculator.
Oh, because it's
-2 times 1 minus -2 to the 9th. And then we'll divide that by 3. And we divide it by 3 because 1 minus a -2 is 3. So it's B.
Is the test in multiple choice?
Test will be just like this, but much shorter.
not shorter.
Much shorter. All right, let's get going because it's going to take forever to upload this video. We're already at 28 minutes. Okay, perfect example. We have 3 being raised to the k minus 1, but there's nothing in front of the 3, right? Here, we had a 2, right? And that was my A1. There's nothing in front of the 3. My A1 is 1.
Oh. Got it.
So A1 is 1, R is 3, N is 8. So we have 1 times 1 minus 3 to the 8th divided by 1 minus 3. And again, we have to be very careful of how we put this in the calculator because this is not -3 to the 8th power. This is 1 minus 3 to the 8th power. So 1 minus 3 to the 8th is going to be that. Also, if you wanted to just do 3 to the 8th and then 1 minus that, you could do that too. Get the same answer. And then divide that by -2. So 3280. So also it's imperative for you guys and anybody listening tonight to bring your calculator tomorrow. Like these are gonna be next to impossible to do without a calculator. You can set it up. Like if you forgot a calculator and you got it to like here and it was all correct, I would take it, but it's gonna give you more anxiety than it would if you just remembered your calculator. Okay, you survived. On to exponents. All right, do I have anything to multiply this 2 by? Is there another 2 or another number? I don't. So then I'm gonna worry with my p to the second times p to the second. When I multiply same bases, I add my exponents. So it's gonna be 2p to the 4th. Hmm? Nope, there's only 2. But I'm multiplying. 2 times 1. So a squared times a squared times a to the 3rd power. When I multiply same bases, I add my exponents. So 2 plus 2 plus 3 is 7. So 2a to the 7th. Next one's going to be a little bit more complicated, and it really depends on what your preference is in doing this problem. If your preference is to distribute this 3, you can. That's what I would do, because then it kind of breaks it out to individual terms. The reason we can distribute this 3, well, -3, is because there is no addition and subtraction in this. If there was addition and subtraction, we would not be distributing. All right, that's one of those things where people like to give it to everything, but you can't, okay? So we have -3, and we're gonna give it to every, and by give it, I mean raise each term to that. Okay? So -x squared to the -3, when we raise a power to a power, we multiply, so that's -x to the -6th. Y, what did I say?
Someone to the reception.
Okay. I swear I heard Goranson. Y to the -1 to the -3. -1 times -3 is +3. So it's just going to be y to the 3rd. X to the -4 to the -3 is x to the +12. And then y to the 3rd to the -3 is y to the -9. Okay? When I multiply same bases, what do I do with my exponents? Right? I'm multiplying these, right? Yeah. So x to the -6th and x to the 12th, what do I do with my exponents when I'm multiplying the same base of x? Add. So -6 plus +12 is +6. So x to the +6, y to the 3rd, y to the 9th. I'm going to add those together. What's that going to give me? Y to the?
6, -6.
Y to the -6. But remember, the instructions say positive exponents only. So what do I need to do with this y?
Make it positive.
How?
Put it on the bottom.
Yep. And so the answer should be right there. I. My chair makes weird noises too. All right. Similarly to the one that we just did, we have another one where we're going to distribute that power. In this case, my power that I'm distributing is positive. So when I raise a power to a power, what do I do, friends?
Multiply.
Multiply. So x to the 15, y to the negative 25, and then negative x to the 25. So now I have, remember I'm multiplying. Even though this is negative x, I'm still multiplying it. Okay? I'll move it up. Sorry, Eliana. Right? So if I multiply same bases, I add my exponents. So this is going to be negative x to the 40, y to the negative 25. But I can't have that negative 25. What do I need to do?
Make it positive.
By
Putting it on the bottom.
putting it in the bottom. Yep. So negative x to the 40 divided by y to the 25. Okay. There's a couple that I'm going to actually take off of here. Okay. Doing good, friends. Hanging in there. Okay. All right, so let's not mess with the top.
Wait, I don't have a problem 19.
You should have 2 pages.
Okay,
Here you go.
I don't see a thing.
We're close, we're close. You're doing good. Okay, so we're not really gonna mess with the top right now. We will, but not right now. Let's deal with the bottom. Power to a power, what do I do?
Power to
On the bottom,
multiply it.
multiply. So I've got, well, let's go ahead and, I said we weren't gonna mess with the top, but same basis, you add the exponent, so that's gonna reduce to this. On the bottom, 1/2 times 5/4 is 5/8. Y to the negative 1 is y to the negative 5/4. If only it were this simple and we could stop, but we can't.
We should just stop.
I know, but we can't. But this is where your trusty dusty calculator can do the hard work for you as long as you know how to use it. So on the top, what do I do, friends, when I divide same bases? What do I do with my exponents? None of you? Maybe if you picked up your calculator and put down your cell phones, 1, 2, 3. I don't care. Keithy will understand. If he has a problem, he can march his Keith soccer person in here and come and drag you out.
Okay.
And tell him I said that too. It's on recording.
I'll just show him the video.
Yep. So this is where you can let your calculator do some of the heavy lifting, because I know that most of you guys are going to be like, Ms. Gorns, I really don't want to do this fractions, right? But if you use your calculator, so right now it'd be 2 minus a negative 5/4, okay? So math alpha y equals, and see how it gives you the fraction? Okay, do you have your calculator, Naomi? Here, just use this one. Eliana, do you have a calculator, dear?
I do. I got it.
Here. I'm not gonna. We win! So 2. Oh, okay. Okay, so 2 minus a negative 5/4. Math alpha y equals, enter. We'll be able to give you the decimal or the fraction. When you put it in as a fraction, watch. It gives it to you as a fraction.
My phone's down. My phone's down. Please tell me you saw that. She's making fun of me. She just turned around and went.
14ths.
I think we should show the class what Eliana just did. I don't even know what I did.
13/4, my bad.
I hope we both did.
So listen, can I stop right now that I know that y is to the 13/4?
Yes.
Why do you say yes?
Because it'd be a lot easier.
It would be easier to stop, but why do I know I can stop?
Oh, like you actually can stop?
I can actually stop. Why? Look at multiple choice. It's the beauty of multiple choice.
I'm looking at multiple choice.
Y to the 13th, 14th. Do I have more than
Because
one?
The answer's there.
No.
The answer's there.
The answer is not there.
Y to the 13 over 4.
I
Well,
said
they said
14,
13.
sorry.
Use your brain.
Yeah, sorry.
To be fair, she was using her listening ears. I said it wrong.
I was using my listening ears.
All right. Power to a power. What do I do?
Multiply.
I multiply.
I'll start answering questions.
Y to the 0. What does this turn into? Y'all, this video is going to be so long, it's never going to upload if we don't finish soon.
Hey, I'm answering the questions.
What was the question?
Y to the 0 is
1.
1. So do I need to do anything with the Y here? Nope. 1 to the 1/2 is still 1. Yep. All right, let's take a look at the bottom. We have x squared and then x to the negative 5/3. When I multiply same bases, what do I do with my exponents?
You add them.
Yep. So 2 over 1 plus negative, what was it? 5/3.
Actually, yes.
Math alpha y equals. Look at that. 1/3. Don't even have to do it.
Yay.
And then you have y to the 1/2 and y to the negative 1/3. So math alpha y equals 1/2 plus minus 1/6. All right, so is there any y to the 1/6 in the answer?
1/6. No. There's 5/6.
So did we do something wrong? Let's see. Let's see. That's 1/6. That's 1/3. Am I missing something? Oh, I know. Okay, I know what, okay, I know what's going on. So here we have, so technically this would be a perfectly acceptable answer. It's not in our answer key because it does not want any fractional exponents in the denominator. It's D. as in dog. But I'm not gonna put one on the quiz like this for you guys. This is a little bit too much. So yeah.
So a whole.
It goes, no, some of them I'm taking away though. We're almost done.
I don't.
We're almost done. Find the product. How do I do that? We're gonna multiply, right?
Yeah.
Let me-
Is it just the?
Yeah, you can use a rectangle.
I thought it was just the.
Or you can do the, what's it called?
Foil. Yeah, whichever one you prefer. I like the rectangle better.
Foil is so much easier and it's less.
It's the same thing. It's the same amount of work.
You don't have to rewrite it.
Same
You
amount of
just
work.
Do the foil from there.
8r squared minus 64r minus 8r plus 64.
Mom, but which is hard?
So 8r squared. Hey, look, which one does it have to be?
See.
Mm-hmm. Then you would do this. And then the next one, since Naomi likes foil better, 5a times 8a is 40a squared. 5a times negative 1 is negative 5a. Negative 6 times 8a is 48a, negative. And then negative 6 times negative 1 is positive 6. So which one is that gonna be? B. All right, dividing. Do we want to use synthetic or long? Okay. Synthetic, we want to do x plus 4 equals 0, x equals negative 4. Negative 4 goes in the corner. And they step down, so we have 3, 2, 1, none. So perfect. You put the coefficients 2, 1, negative 21, positive 28. Bring down the 2. Negative 4 times 2 is negative 8. Negative 4 times negative 7 is negative 28. Positive 28. And then that's 7. Negative 4 times positive 7 is negative 28, 0. So because it started at x cubed, we're going to step down. So this is 2x squared minus 7x plus 7. With no remainder, it's D. Next one, I can do long on this one. Or synthetic, it's up to you. Which one do you want to do? Long? Sure. X plus 4 divided by x cubed minus 3x squared minus 35x minus 28. I want to make this x look like this x cubed. What do I have to multiply this x by? Well, I have to multiply by x squared, right? So x squared times x is x cubed. X squared times 4 is 4x squared. And in true division, we're going to subtract. Those are going to cancel. This is going to be 1x squared. And I'll bring down the 35, negative 35.
Wouldn't that be negative 1?
I want to make this x look like this x squared. What do I have to do?
35. I'm lost.
Wait, when did you ask?
Oh, because it's just square one, right?
Okay. Something's off here. Let's see what I did. Oh, I know what I did. Silly me. Do you see what we did wrong? Nope. When I subtract in true division, I subtract both. So this is -3, and that's -4, which would be -7. So this needs to be,
I thought it was +4 though.
it is +4 here, but I subtract, so I have to subtract both. Now, -7, so it's -7x squared minus 28x. But remember with division, we subtract, so those are gonna cancel, and that's gonna add, and that's gonna be 7x. That should be a 28. It's messy. Yeah? Now I want to make this x look like this 7x. What do I have to multiply by? Not a trick question.
Oh, 1.
Oh, and it's negative.
1.
Nope, -7. I want this x to look like this -7x. So -7x times x is -7x. -7 times 4 is -28. But remember, in division, we subtract, which turns both of these positive, and they both cancel, and we're given no remainder. And that is answer number B, letter B. This is,
Almost an hour. It's gonna take 10 minutes.
we have 2 more. We can do it. You ready? We're not doing the last 4. So technically, these would be hard to do. You could do this one. You could do this one, but the other ones would be hard to do. All right. Long division or synthetic?
Synthetic.
Okay. So this would set equal to 0. B would equal 7. So 7's gonna go in that little box. And it's b squared. Oh, but look, we have a b cubed. So, and it's not in order. So 1, -6, -2, -35. Because look, it needs to be descending. So b cubed, b squared, b, no variable. Make sense? We're gonna bring down the 1. 7 times 1 is 7. Add, and we're gonna get 1. 7 times 1 again, 7. Add, and we're gonna get 5. 7 times 5 is 35. So this would be b squared, b, and 5. Hi, Sarah. I know, we're almost done. Last but not least, synthetic or long? Long. So cubed, squared, 1, none. So we're good. You would think as a math teacher I could draw a straight line. I'm telling you. And or that it wouldn't bother me, but it does. How do I get this v to look like this 7v cubed? Multiply by 7v squared. 7v squared times v is 7v cubed. 7v squared times 6 is 42. V squared. Remember, with long division, we subtract. Those we're going to cancel, and that's going to give me 1v squared. I multiply this v by v, to make it look like 1b squared. V times V is V squared. Oh, I forgot to bring down the 12b. V times 6 is 6V. But remember, we subtract. Those are going to cancel. And then I'm essentially going to subtract that one. And so that would be 6V. 6 times V is 6V. I bring down that 36. 6 times 6 is 36. But remember in math, long division, we subtract. Those two are going to cancel and it gives you 0. So 7V squared plus V plus 6 is D. And we're done.